Welcome to the companion video for Chapter 3 of A Parent's Survival Guide to Common Core Math. In this section, we're talking about building students' recognition and intuition about numbers. So we're talking about the youngest students. So if it seems at some points like what we're working with here is very simplistic, it is, and it's intended to be so. In the chapter, we covered 3 different areas of how to strengthen a student's concept of numbers beyond the symbolic. So sometimes we talk about numbers and all we really think about is the digit 1 or 3 or 8, whatever that digit is. And we think about the actual, like, 8, the number 8. That doesn't mean a lot to a kindergartner who's coming in and sees a symbol and doesn't have that link to actual a firm, concrete meaning. So what we want to do is help them to connect the symbol with something real. So let's check out our first example here, which is a 10 frame. You'll see right here I'll hold it up to the camera so you can see it straight on. We have a 2 by 5 rectangle with equal spaces within them. And we use this to represent different numbers. So for instance, let's say that I as a teacher am talking to a classroom of students and I say, all right, you have a handful of 2 colored discs. I want you to select the quantity 8. So for young students, they usually, when they think about 8, they need to count from 1 up to the value of 8. So they might select 1, 2, 3, 4, 5, 6, 7, 8, and then put aside the rest. So they know they've counted out that they have the quantity 8 here. So my next assignment is take the discs, the 8 discs, and represent them on the 10 frame any way you choose. So one student might take their discs and fill in a whole row, and then move on to the next row. 1, 2, 3 more. So here, without even knowing anything about addition or anything more complicated than just the quantity 8 itself, they've actually represented 8 as 5 and 3. Kind of an interesting addition fact that will mean more to them later, but now they're experimenting with it anyway. A second student might say, oh, I actually have placed it in 2 equal rows of 4. So 1, 2, 3, 4, 1, 2, 3, 4. Or you might have the clever student who really wants to do something a little bit different, and they say, oh, well, Mrs. 9, I have represented the number 8 like this. So I have a missing piece over here and I have a missing piece over there. And all 3 of these representations are correct. Even though they're different, they're still a representation of the number 8. And you might ask, well, is that really helpful if every student is coming up with a slightly different answer to your question? And I would say yes, and let me show you why. So looking back down at our 10 frame, there is one especially common theme that you're going to notice with all of these representations, whether it be this one, or we didn't even look at this one before, this one, this one, this one. No matter how we orient these discs, we always have 2 spaces free. And you don't even have to instruct a student in this, because as they're experimenting with moving the discs around, that's going to become apparent. No matter where I put my discs, there's always going to be 2 spaces left over. And so we're teaching them 2 different things about 8. We're teaching about a present quantity. So there are 8 discs. We can look at it as 3 and 5, 4 and 4, etc. And we're also teaching them about the number 8 in terms of an absent quantity. There are 2 absent spaces. In relation to 10, the number 8 is 2 less than 10. Now, why is this important? You may, if you've already read through the chapter, you may recall the phrase making 10, which is a phrase that's being used more and more often now to help students think about numbers in terms of how far above or below the number 10 that they are. And why is 10 important? Well, we use a base 10 system. So if you think about place value, which we'll talk about more in chapter 4, we have ones, tens, hundreds. Then we have thousands, 10,000s, 100,000s. Then we move to millions, 10 millions, 100 millions. We're always moving up in increments of 10. We like multiply by 10 and by 10 and by 10. So everything about our number system is related to the number 10. So that's why when we add, subtract, multiply, divide, the number 10 comes up over and over and over again. So at the very beginning, even in kindergarten, we want to be talking about numbers in a way that's going to lead them to be thinking in that direction. We don't have to tell them that it's important for them to know about the number 10, but we're going to structure their learning in a way that will make that a little bit easier for them in the later grades. So that's what a 10 frame does. As far as showing a quantity, it also, so that's kind of building into the idea of number intuition, but it also helps them with number recognition, being able to quickly identify a quantity just by looking at it. So for instance, I have some 10 frames here that are already completed. So you have, this is 3. This is the quantity 5. Here's another 8, which we already looked at. I don't know if I'm covering the circles here. And then another 8. These sorts of cards, now we can do this from 0 up to 10, and then we could actually combine them and make numbers that are greater than 10. I could use these in a classroom and hold up, take an example here, I could hold this up to a class who maybe would have, each student has a number digit that I've given to them. So maybe they have a piece of paper with a 1 or a 10 or a 5 on it. And we could make a game out of it where I say, all right, when you see your number, jump up as fast as you can. And I hold it up and the students are engaging with the material in a way where they're excited to see how quickly they can identify that number. Now, why is that important? Well, because we want to be teaching their brain to connect with quantities in a very exact manner, I guess is a good way to say it. Like not just to see 8 as a bunch, but to see it as 8. And 10 frames help us to do that.